Okay, so 6.3 is solving right triangles. So let's go back and talk about triangles that we know. So first off, if we have side lengths A, B, and C on a right triangle, we know the Pythagorean theorem says a squared plus b squared equals c squared. That's a way of relating all the sides to each other. We also know, if we know the interior angles of a triangle, let's call them alpha, beta, and the right angle is going to be right. We know that the sum of the interior angles of a right triangle is 180 degrees. So if I subtract off my right angle, I'll have 90 degrees left. So that lets us know that 90 degrees minus alpha minus, we'll say it like this, alpha plus beta is equal to 90 degrees. So we can use that fact to relate the interior angles together. Also, if I have side length theta on a right triangle, and this is going to be our adjacent side, this is my opposite side, and this is the hypotenuse. We know that sine of theta is, and remember, this is our SOHCAHTOA that I talked about. If you can remember that, you can remember all these trig functions. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant, I'm running out of room. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotan is adjacent over opposite. Okay, so what we're going to do is we're going to use these three facts here, the relating the Pythagorean theorem, the sum of interior angles, and all of our trig functions to solve for right triangles. So let's look at an example. Let's solve this right triangle. Let's say I have a right triangle with our angle here is 32.2 degrees. Our hypotenuse is 6.25 feet. And we don't know that side, this side, or this side up here. Alpha. Okay? So, C is 6.25 feet. And beta is 32.2 degrees. Now let me pause right here and tell you something. When you're using your calculator and you're going to use trig functions in your calculator, you need to first determine if it's in degree or radian mode. Now, we're going to do a lot with radian, so you'll probably keep it in radian mode most of the time. If you click the mode button on your calculator, it's beside the second function, about halfway down, or not halfway down, a couple lines down, you'll see degree or radian. Whichever one's highlighted is whatever mode your calculator is. So this problem is in degrees, so let's change it to degree mode. Okay, so when we do that, let's figure out all the other pieces. So, how do we figure out, let's first figure out alpha. Alpha is going to be 90 degrees minus beta, which is 90 degrees minus 32.2, which gives me alpha to be 90 minus 32.2 is 57.8 degrees. Okay? So there is the other side length. The other angle measure. Now, how do we find the side lengths? Well, we've got to use our trig functions to figure those out. So we're given beta. So we know that sine of 32.2 degrees is opposite over hypotenuse. Okay, so there we just solve for b, which is when you multiply both sides by 6.25, you get sine of 32.2 degrees. So b, if you put that in the calculator, there's the sine button, make sure it's in degree mode. You put 6.25 times sine of 32.2, and you should get approximately 3.33 feet. Now, to get the other side length, you can use the Pythagorean theorem, or you can do what we just did. To find A, we can use cosine of 32.2 degrees, which is A over 6.25. So A is 6.25 times the cosine of 32.2, which is approximately 6.25 times cosine 32.2, and it is 5.29, approximately. Okay, so that's how we solve right triangles. We use whatever information is given to us, and the Pythagorean theorem, or the sum of interior angles, or this guy, all the trig functions, to solve for whatever is missing. Okay, now in your calculator, there's second functions of your trig functions. You see sine inverse, cosine inverse, and tan inverse. Those in your calculator is saying what angle would produce a sine of a given thing. So on this other problem here, we knew that well, let's just say we find sine of 30 degrees. Okay, sine of 30 degrees is 1/2. Okay, so if we wanted to say what is sine inverse of 1/2, it's asking you what degree angle gives you a sine of 1/2, and it would give you 30 degrees. So it's going to give you the angle back. Okay, so you can use this for solving for trig functions as well. Let me show you. Here is a triangle, right triangle. We don't know beta, we don't know alpha, but we know the legs is 2.62 and 4.32, and we don't know the hypotenuse. Okay, so let's find all the other measurements. So let's first start out with finding beta. So we know that we don't have the hypotenuse, so we need to use a trig function that doesn't include hypotenuse. Now, tangent is opposite over adjacent. That doesn't include the hypotenuse, and we know our opposite and adjacent. So let's say tangent of beta is 2.62 over 4.32. Okay, so then if we want to find beta, if we do the tan inverse, that changes this guy around to this and tells you beta. So this gives me beta to be approximately equal to, using the calculator, tan inverse of 2.62 divided by 4.32 is approximately 31.24 degrees. Okay. If we want to solve for alpha, that's just going to be 90 degrees minus this guy that we just found. We could do it using the trig function, or we can just do it this way because it's easier. So that gives me 31.24. That gives me alpha to be equal to 58.76 degrees. Okay? And then, how do we solve for C? Well, there's a couple of different ways of doing this. But you see that we can do sine of beta equals the opposite over the hypotenuse. Okay? And we know that beta is 31.24. Okay, so then if we want to solve for C, we multiply both sides by C, then divide by that. So C is 2.62 divided by sine of 31.24 degrees, which gives us approximately 2.62 divided by sine of 31.24, 5.05. No, yeah, 5.05. Okay? So that's how we do it. If you use the Pythagorean theorem, though, for C, it'd be easier. You could just say a squared plus b squared equals c squared, and you could have done 2.62 squared plus 4.32 squared equals c squared, and solved it that way. Would have got the same thing. Okay? That's how we do solving solving right triangles using trig and stuff like that.